Welcome back to True North Mechatronics. Today we're solving one of the biggest failure points from version 1 of the Sparkbot, exposed wiring over the logic boards. To fix this, we're engineering the Vetronics Enclosure. This enclosure performs 3 critical functions. First, completely protects our wiring. Second, it adds massive rigidity to the rear of the chassis. We're designing front fingers that hook onto the battery box flanges and rear corners that press into stop blocks on the mobility base, turning this entire enclosure into a solid compression member. Third, the enclosure functions as a mechanical safety interlock. The enclosure cannot be physically removed while the battery is installed. Design, engineer, deploy. Let's get into the CAD. Begin by creating a new body and a new sketch on the XY plane. We're going to use the polyline tool, and we're going to map out the basic outline of what the enclosure sides are going to look like. We will constrain our outline horizontally and vertically here. We've got this done. Our basic shape is going to look something like this. First thing that we have to do is we've got to find those lines that were not horizontally or vertically constrained. That looks like the only two. Now that we've done that, we're going to take these 2 points here and we're going to constrain them symmetrical around the y-axis, and we'll set the vertical length of this inset to 3 millimeters. These are going to be the points where that connect to the top of the enclosure deck. So these are going to be our anchor points. So set these so that they're equal, and we will set these to 8 millimeters. This is the pattern that we've used for the battery box as well. And let's constrain this inset here to 76 millimeters. Okay, so now that we've done that, we're going to turn our attention here to the sides. So we're going to make the sides symmetric with respect to the x-axis. And we're going to set the dimension on this to 58 millimeters. Now that we've done that, we can constrain our bottom. And let's constrain that to 79.3 millimeters. Bring this up like so. Bring that over. Okay. So this is going to be constrained at 8.2 millimeters, and this top portion here at 3.2 millimeters. Right. Now let's turn our attention to the top over here. This is going to be constrained at 28 millimeters. This top portion here at 10.5. And this segment here, we'll constrain that at 3 millimeters. Okay, so with that, we've got most of the outline complete. We're going to add an arc here. So let's select Create Arc by 3 points. And we're going to select those 2 points here. And we're going to constrain this arc to 22 millimeters. All right, so there is our fully constrained shape. And we can see all of our constraints there. So let's close out of the Sketcher workbench now. And we're going to pad this shape out to 3 millimeters. Next thing that we're going to do is we're going to add the rectangular sockets. Those will be used for locking the lid of the Vetronics enclosure to the sides. So let's use our rectangle tool, and let's create 3 rectangles. We're going to make it so that these 2 outer rectangles are symmetric with respect to the y-axis. We'll make the internal rectangle symmetric around the y-axis. Then we're going to make sure that all 3 rectangles have an equal length and that they have an equal width. And lastly, we want to make sure that the outer triangles are collinear with the center triangle. So we do it like that. Now we're going to constrain our rectangles here. So 10.2 millimeters in the horizontal and 3.2 millimeters in the vertical for our rectangle. And let's set the distance between the inside points of our outer rectangles. Set that to 53.8 millimeters. And now our rectangles move as a group. So we need to constrain them with respect to the top of our enclosure side. And we'll do that by setting a vertical distance of 1.9 millimeters. All right. And before we close out of this, we're going to add the 2 anchor points here that we will use for attaching to the mounting bosses on the top plate that we build in a later video. So let's make these 2 circles so they're symmetric around the y-axis. Let's give them equal diameters. And let's set the diameters to 2.8 millimeters. And then we will position them with respect to the top of our side rail here. And that's going to be a 3 millimeter offset in the vertical. And it will be a 4 millimeter offset in the horizontal. And with that, we have fully constrained the rectangular sockets that will hold on the top of our enclosure. So we can close out of the Sketcher workbench, and we're going to pocket this through our shape, accepting the default of 5. All right, now the next thing that we're going to do is we're going to add our triangular truss pattern here. This is for lightweighting. It reduces the amount of plastic used for producing the part, and it matches our overall design aesthetic that we've been maintaining throughout the project. So again, with the polyline tool here, we're going to rough out 4 triangles. And making sure that you don't actually click on any of the axes here, because your triangle will end up being constrained or locked to that axis. And now that we've got that, let's create some symmetry here. So let's set all the bases so that they're the same, all the same width. And we're going to set the sides of our triangles so that they're all the same length. Now that we've done that, we want to make we're going to make the top portions of our triangles so that they're collinear. We're going to do that with some construction geometry. And now I'm going to make sure that, so I've got 2 of these that are horizontally constrained. I want to horizontally constrain this one as well. Now that I've done that, I'm going to set all 3 of these pieces of construction geometry so that they're equal to each other. And I'm going to set the length of the construction geometry to 5 millimeters. And by doing that, I now am able to move these triangles symmetrically. We're going to reference 2 more edges. Let's reference this left edge and this right edge. And we're also going to reference this top inset edge. All right. Now that we've done that, let's set the offset on the left to 6 millimeters. Let's set the offset on the right to 10 millimeters. The reason we're setting this to a larger offset is we need to create rectangular sockets here for the back of the enclosure for the Vetronics deck. And now we've got 2 degrees of freedom, so that will be movement of our truss pattern along the y-axis. So let's set our offset from the top at 8 millimeters, and we'll set our offset from the bottom at 10 millimeters. Let's do that. We are. All right. And so now we have fully constrained our truss pattern here, so we can close out of the Sketcher workbench, and we'll pocket this all the way through. And the next thing that we're going to do is we're going to add a feature on the bottom of our enclosure edge, and this will be used for both locking the enclosure to the mobility base so that the enclosure can't move up and down. It will also be used for creating some back pressure so that the enclosure presses against a stop block here. So we're going to reference the bottom of our enclosure side here, and we're going to create a rectangle. Make sure you don't click on the y-axis because it will lock to that. You don't want that. Let's set the dimensions of our anchor here. So this is going to be 5 millimeters in the vertical, 20 millimeters in the horizontal, and we'll set the offset distance from the end. We'll set that to 30 millimeters. And so our shape is fully constrained, so we can close out of the Sketcher workbench, and we're going to pad that out to 10 millimeters. And now that we've done that, we're going to add some functional as well as cosmetic fillets. So let's begin with the cosmetic ones. So we're going to come up here, and we're going to select these edges. So hold down, I'm using the blender keys, so I'm holding down Control as I select the second edge. Control click, and now I can give that a fillet of 2 millimeters. Try that again. I think I got that. Nope, 2 millimeters. All right, there we go. And now we need some functional fillets here. So we're going to select these two edges here. Now these need to be rounded so that when we insert this, or rather when we attach the enclosure later, we don't want these corners catching and rubbing and blocking the movement of the enclosure. So there we are. We're going to add these fillets here at 2 millimeters. And we're going to add some fillets to these bottom corners here. So 1 and 2 here. Now we're going to give these ones slightly larger fillets. So we're going to give that a 3 millimeter fillet there. And those ones are all functional. These ones are a combination of functional and aesthetic fillets. We want to select those two edges there. And we want to select these ones as well. So I've now selected 4 edges, and we're going to give this a 2 millimeter fillet. There we go. And so it gives that profile there. Have a look at it from the edge. Okay. So now that we've done that, we have created the basic profile for the side of our Vetronics enclosure. Now what we need to do is we need to modify the right-hand side of the enclosure. So let's rename this one. This one's our left side. And now we're going to move over to the part workbench. And here in the part workbench, we're going to mirror the side that we just created. We'll use the mirror tool. And we're going to specifically choose the XZ plane for our mirroring operation. That gives us our other shape here. Now what I'm going to do here is I'm going to create a new body. So I'm going to go back over here to the part design workbench. I'm going to create a new body. And in this new body, I'm going to drag the mirrored shape over here. And when we do that, I'm going to right click and rename this. So this is the right edge. And now I want to move this out so I can see it a little bit. So I'm going to transform it. I'm going to select the green arrow there and move it out. Select that default. Now I'm going to do a little bit of work on the right-hand side here. So for right now, I'm going to hide the left side. Let's left click on the top face of our right Vetronics side, closure side. Now we're going to reference the right hand side and use the rectangle tool, and we're going to create 2 rectangles. This is going to hold the back plate on our Vetronics enclosure. Let's set the vertical length of both of these so that they're the same, and the width of both of our rectangles so that they're the same. We're going to set the vertical dimension to 8.2 millimeters, and the horizontal dimension will be 3.2 millimeters. The offset between these two will be 13.8 millimeters. We need to make it so that these are collinear, so I'm going to select this edge and this edge here. And this now makes them collinear, so they will move as a group now. Let's constrain them away from the edge here, so we'll set that to 2.9 millimeters. And then we will set an offset from the bottom here at 12.5 millimeters. And so with that, we have fully constrained the two new rectangular sockets that will hold the back of the Vetronics enclosure on. So we're going to close out of this and pocket those through, accepting a default of 5. And that completes the side panels for our Vetronics enclosure. By engineering those front pivot fingers and the rear locking flanges, we have set the foundation for a rigid compression member that protects our delicate wiring and forces a strict hardware-level safety protocol for battery removal. In the next video, we will cap off this module. We're going to design the top cover, utilizing the same heavy-duty tab and socket architecture we used on the battery box. Chart your course, build your world. I'll see you in the next one.